This lecture continues talking about polynomial functions and their graph by now moving into understanding the relationship between the degree and turning points, and then finally building towards graphing by hand these polynomial functions. So what we've talked about before, so what we've done in the previous two lectures, we've talked about the end behavior of graphs of polynomial functions. We've talked about how you find the zeros of polynomial functions, and then we've talked about the multiplicity of the zeros of polynomial functions. So now what we're going to do is we're going to pull all this together, and I have three examples here working through how you sketch the graphs of these polynomial functions. So let me skip to that in our lecture here. Okay, and the first thing is talking about the turning points of polynomial functions. So in general, if f is a polynomial function of degree n, then the graph of n has at most n minus 1 turning points. So for example, if you were to look at this, so I'm just going to make this function up. F of x is equal to 3x to the 5th power minus 7x to the 4th plus 2x minus 3. Okay, this is degree. The degree here is 5. So what this means is if we were to sketch this graph, whatever it looks like, and we're not going to actually do this example, but whatever this graph looks like, this graph would have at most so it's n minus 1 turning points, so at most 5 minus 1 is equal to 4 turning points. Okay, so look, this is a degree 5 polynomial with a positive leading coefficient. So this graph would look something like this. It could have this is 1 turning point, 2 turning points, 3 turning points, 4 turning points. It could look like this, okay? So look, here's turning point 1, 2, 3, and 4. That's what I mean by these turning points, okay? These peaks and valleys here, okay? All right, so now what I want to do is I want to pull this all together and talk about a strategy for graphing polynomial functions. And there's a lot going on here, okay? So the first example, I'm going to have it mostly printed out in the PowerPoints, and I'll walk you through it, and then we'll do two where we'll write everything out. Okay, so there's this process to it. The first thing you're going to do is you're going to use the leading coefficient test to determine the graph's end behavior. And just going back in the lecture real quick, it's this right here. This is step 1 of our strategy. Figure out what the end behavior of the graph looks like. And then what we're going to be doing is then we're going to figuring out the middle part of the graph, like the turning points here in the middle. That's the harder part of this. Okay. The next thing you're going to do is you're going to find the x-intercepts by setting f of x equal to 0 and solving the resulting polynomial equation. Okay, so you're going to find the zeros. All right, the next thing you're going to do, if there is an x-intercept at r as the result of this type of factor, x minus r to the k power, okay, in the complete factorization of this function, this polynomial function f of x, all right, then you're going to recall the multiplicity. Now, I covered this in a previous video lecture. All right, but if k is even, okay, the graph touches the x-axis at r and turns around, so it's going to be, going back real quick, going to be like this situation here, whoop, just touches and turns. All right, if k is odd, then the graph crosses the x-axis, it goes through it, so going back, it's going to be like this, it goes whoop, goes right through it. And then just remember, if k is greater than 1, the graph flattens out. Even if it's going to cross through it or turn, it flattens out as it gets near that x-intercept. Excuse me. Okay, so these are really important to recall. Next, you're going to find the y-intercept just to have it. So basically what you're doing is you're plugging 0 into the function, okay? And then you're going to have this new point. Excuse me. 0 comma f of 0, this is the y-intercept. Then you're going to use symmetry if it's applicable to help you sketch the graph. This is the least important part. Okay, and you can often skip this. You'll see I'll only talk about this real briefly in the first example. And then finally, 5, you're going to use the fact that the maximum number of turning points of the graph is n minus 1. Okay, well, this is again where n is the degree of the polynomial function to check whether it is drawn correctly. And I'm just going to add one little point here. You're going to find additional points as needed. And you'll see me do this. You can also use a graphing calculator to verify. And you'll notice that I'll do that, okay? And the 2 examples that I'm going to do by hand, I'm going to do the rough sketch, and then I'm going to just load up my graphing calculator and just take a look. Did I do this correctly? All right, so he'll be the first one. So I have this all written out for us in the lecture here. And so I'm going to do this one, just, walk you through it here and explain each of the steps that are written out, and then we're going to do 2 by hand. Okay, so use this 5-step strategy to graph this. So f of x is equal to 2 times x plus 2, and that's squared, times x minus 3. Okay, so the first thing you're going to do is you're going to determine the end behavior. So notice how you have this 2 out in front. This is still the leading coefficient. Okay, so identify the sign of the leading coefficient. Okay, so the sign, so we see a sub n is equal to 2, which is greater than 0. And now in the degree n of the polynomial function. So you'll notice here that what we're saying here is the degree is 3. So it's like, how do I know that by looking at this? So there's a cheat way you could do this, right? So you're going to have x squared, and then eventually you're going to times it by x. Well, x squared times another x, that gets me x cubed. So the highest exponent is going to be a 3. So the degree is 3, which is odd. Okay, so look, the leading coefficient is 2, it's positive. So what that means, degree 3 odd, leading coefficient is positive. So just going back to this real quick. I know I'm going quickly. Degree 3, so it's odd. Leading coefficient is positive, so it's going to rise to the right and falls to the left. Okay, so as I sketch this graph, I know that it's going to rise as I go to the right. As x increases, it's going to rise. And as I go to the left, it's going to fall. Okay, so look, awesome. I know what the end behavior of this graph looks like. Now I just need to figure out what it's going to look like in the middle here. The next thing you're going to do is you're going to find the x-intercepts. Okay? All right, so you're going to set this equal to 0 and solve. So look, when you set this function equal to 0 here and solve, the 2 doesn't matter. Okay, this just, you divide by 2 and it goes away. All right, so you're going to take this right here and you're going to set it equal to 0, or you're going to take this. So look, over here you see you have x plus 2 is equal to 0, so one x-intercept is x is equal to negative 2. But look, it had this squared, so it had multiplicity 2. So that's an even multiplicity, right? Here, there's an invisible 1 here, okay? So another one, when you solve x minus 3 is equal to 0, you get x is equal to 3. That is a multiplicity of 1, so that's an odd. So what does that mean, okay? Look, when you have a multiplicity of 2, so x is equal to negative 2 is a 0 of multiplicity 2. So what that means is the graph is going to touch the x-axis at x equals 2, flatten and turn around. Okay, so I'm going to show you what's going on here. Okay, instead of just talking about it on the graph here. So when you have this x-intercept of negative 2, so it's going to touch the graph. Well, we know if it's going to touch and turn here, the end behavior tells me on this end it has to go down. So I know it's going to touch and turn down here. At x is equal to 3, all right, the multiplicity is 1, so it's going to go through it. So what that means, if I know as I go to the right it has to go up, it's going to cross right through it. Okay, so it's whoop, so it's going to go there. So look, now I just need to figure out what's going on in here, all right? So I'm going to find the y-intercept by figuring out what f of 0 is. When I plug 0 into this, I get negative 24 just to save a little bit of time. So look, as you're finishing out the graph, whoop, it's going to touch at negative 2, and then the y-intercept is going to go down to negative 24. But now what I'm missing here is a little bit of scale in between, but I'll talk about that. Okay, so to help us determine how to scale the graph, we're just going to find some extra points, like I said. So look, you know, I know what happens at x is equal to 0. Let's find out at what the graph comes out when you plug in 1 and you plug in 2. And when you do that, you get negative 36 and negative 32. So look, I have 2 additional points. This is the point 1 comma negative 36, and this is the point 2 comma negative 32. So these are extra points that I can plot to help me sketch the graph. So just looking at the graph, I can see there's no symmetry. Okay, so there's no symmetry that's going to help me solve this. So then all you're going to do is using the end behavior and the additional points, just sketching in those 2 additional points here, you can kind of see how you're going to sketch this. You're going to draw nice smooth curves through it. All right, and you're going to notice when I do it by hand, it's not going to be perfect. But so the next thing you're going to do is you're just going to verify, okay, did my graph look good? So it's a degree 3. So that means the maximum number of turning points should be n minus 1. So 3 minus 1 is 2. All right, so because the graph has 2 turning points. So look, here's the first turning point 1, and here's the second turning point 2. We've sketched this graph correctly. All right, I know there was a lot going on there. So let's do 2 more examples, okay? So we can illustrate this, and we'll do it by hand. And we'll figure out if we got these concepts down. All right, so let's sketch the graph of this. F of x is equal to x cubed plus x squared minus 4x minus 4. All right, so 1. Let's figure out the end behavior. Well, look, degree 3. Okay, leading coefficient, a sub n is equal to, well, there's nothing there, so there's a divisible 1, which is greater than 0. So what does this mean? Okay, going back to our chart. Going all the way back in the slides, okay. Odd leading coefficient, so it's going to rise to the right, fall to the left. So over here on this slide, so what this means is on this side here, as I go to the right, however I sketch the graph, it's going to need to go up. And as I go to the left, it's going to need to go down. Okay? All right, so look, going back. You know, what is step 2 here? If you need some help to go back and look at this, right? So step 2, we're going to find the x-intercepts of this. So x-intercept, so the second thing we're going to do is find the zeros. So to find that, I'm going to take this, I'm going to set this equal to 0 and solve. So it's x cubed plus x squared minus 4x minus 4 is equal to 0. I'm going to group the first two terms together because it's a 4-term polynomial. This becomes 4x plus 4. I can factor out an x squared. I'm going to factor out a 4. Well, look here. So I have x plus 1 times x squared minus 4 is equal to 0. Well, what does x squared minus 4 factor as? This factors into x plus 1 times x minus 2 times x plus 2. Wow, a lot going on here. Well, look at this. If I set all of these equal to 0, you can just see this really very easily, right? So you have x plus 1 is equal to 0, or x minus 2 is equal to 0, or x plus 2 is equal to 0. So that means I have x-intercepts at x is equal to -1, x is equal to 2, and x is equal to -2. They all of them have multiplicity 1. So what that means is all of these x-intercepts, they all cross the x-axis here. So the graph goes through these x-intercepts. So look, let me plot these. So I have -2, -1, and 2. So here's going back. -2, -1, and 2. -2, -1, and 2. So here's what's awesome, right? So you're going to cut through this, okay? So that means, and I know the end behavior, so that means on this end it's going to have to come down this way. And on this side it's going to have to come back up this way. All right, so let me just get a little bit more information here, okay? So the next thing you're going to do is you're going to find the y-intercept. Okay, so I'll do this on this next slide. So my function was f of x is equal to x cubed plus x squared minus 4x minus 4. So you can see here that just f of 0 is 0 cubed plus x plus 0 squared minus 4 times 0 minus 4. It's just minus 4. So look, you can fill out a little bit more here, right? Okay. So to go from here to here and down to here, it's going to have to turn. Now let's just get a little bit more scale here, okay? Don't worry about symmetry. You can see here that no real symmetry on the x or y axis here. So let's get an extra point as needed. So just for a little scale, let's figure out what f of 1 is. So you're going to get 1 cubed plus 1 squared minus 4 times 1 minus 4. So this is 1 plus 1 is 2, minus 4 is minus 2, minus 4 gets me minus 6. So I'm just going to go down, and I'm going to scoot back up here. So it's going to have to look like this. And this is not perfect, okay? Just a sketch. It's not perfect. But so recall also, should have at most n minus 1, which is 3 minus 1, which is 2 turning points. Which it does. Look, 1 turning point, 2 turning points. All right, let's grab our graphing calculator and let's verify and see if this is what it looks like. So I'm going to use my y equals. So I have x cubed plus x squared minus 4x minus 4. All right, let's see what the graph of this looks like. Yeah, look at that. Looks really similar. Like just like that. So look at that. We were able to use just the things that we've talked about in this class to be able to sketch the graph and replicate, you know, obviously not as smooth and as great as the graphing calculator, but you got the idea. All right, let's do one more. Okay. Let's sketch the graph of x cubed times x plus 2 squared times x plus 1. Okay. So 1, end behavior. So what degree is this? This is tricky. So I have x cubed times an x squared times an x. So 3, 2, 1. The degree here, okay, is 3, 2, 1 is 6. So it's an even, and the leading coefficient is a 1, which is greater than 0. So what does that mean if you go all the way back? Now forgive me, I'm going to do this really quickly. Even, okay, the degree is even and leading coefficient is positive, so it's going to rise to the left and rises to the right. Okay, so rises to both left and right. So looking here, so however I sketch this, it's gonna need to rise to the right and rise to the left. Let's find zeros. So the x-intercepts. So here, I'm going to set this whole thing equal to 0. So look here, you have 3 factors. You have x cubed is equal to 0, or you have this x plus 2 squared is equal to 0, or you have this x plus 1 is equal to 0. Well, the only way this can happen is x is equal to 0, but look, the multiplicity, the exponent was 3. So it's an odd. So what does that mean? It's going to go through. The graph goes through x equals 0. Goes through. Here, when you solve this, x plus 2 is equal to 0. You get x is equal to negative 2. All right, but look here. The multiplicity is equal to 2. So what that means is it's going to turn at negative 2. Here you get x is equal to negative 1 when you solve this, right? And so what this is, multiplicity is 1. So that means it goes through. At x is equal to negative 1. All right, so look, I've got x-intercepts, so I've got 3 of them, okay? I've got negative 2, negative 1, and 0. So I've got negative 2, negative 1, and 0. And look, it's going to go through, it turns at negative 2, okay? Turns at negative 2. So what that means, if it's going to have to go, end behavior is telling me it's going up this way, is it's going to turn here, turn real quick here, all right? And this is, you can basically see what the graph is going to look like. And it's going to have to go through each of these. It's going to have to go through each of these. Just to help see here, the y-intercept, just so you can see. If you were to plug in f of 0 here, if you plug 0, and even just looking at the first, you get 0 cubed would wipe everything out. So you get 0. So it would also be the point 0, 0. So look, I'm going to do 4 and 5 here. You don't need any extra points. So look, it turned here. Now it has to go through each of these. So it's turning here, and then it's going to go through, and then it has to go back up. So whoosh, whoosh, like that. It can have at most 5 turning points. At most 5 turning points. That doesn't mean it needs to have 5 turning points. It's just going to have at most. And look, it has 1, 2, and we got it. We're good. Now let me verify. Maybe you're like, I'm not so sure, Matt. Well, let's take a look at our graphing calculator and verify. So it was x cubed, and then in parentheses, x plus 2 squared, and then another in parentheses, x plus 1. Look, you can see it. And I'll even zoom in so you can see here. Yeah, look at that. It bumps at -2, it bumps at -1, 0, and then it shoots up. So we have it. We got it. So look, big thing here, as you can see from the second example, end behavior and intercepts. Okay, and then you need to know the multiplicity of the intercepts, and that will help you, really help you sketch this graph. All right, I hope this helped, class, and obviously you're going to get a chance to practice all this.